All right, let's take a look at day 3 for graphing trig. It's going to get a little bit more advanced today. Reminder of standard form, and disregard the scribbles. I changed my mind on how I wanted to do some things here. But in our standard form for sine or cosine, we could replace that. A represents the amplitude. B is the period change. You can find that new period by doing 360 divided by that value. C is the phase shift, can be added or subtracted, and same with D, can be added or subtracted, but that is the vertical shift. All right, so I'd make sure that I have this handy. This is essentially your go-to. All right. So in our first function that we're going to graph here, I've got y equals 3 times sine of x plus 90. So in this function, I have an amplitude of 3. Denoted by the 3 right there. There is no new period. All right, so I don't have a b value in this problem. I do have a phase shift. That plus 90 will shift my graph to the left 90 units, and at the end there is no vertical shift, so nothing to be done there. So as I go ahead and graph this function, when I think of all of my sine values, well, sine would start at 0, 0. But this time, I'm just going to start over to the left 90 units. And let's go ahead and label our axes here. We'll go 1, 2, 3, -1, -2, -3. I'm starting over at, instead of 0, 0, I'm going to the left, so my first point will be here. Now, my next point is going to follow that sine path, like this, all right? But instead of going right 90 and up 1, I do need to adjust for my amplitude of 3. So I will go up 3 units right there. And then as I travel 90 more degrees, I'll go back down to 0. At 180, I go down to -3. And at 270, I am back to 0 to complete one period of my function. So I will connect now. And if I needed to, I could get this next point. I'd just go up to +3 at 360. Would continue like such. So there we go. Just a little bonus action right here. Reminder that for sine and cosine, your domain is always all real numbers. And this time for my range, I would say that my range is going from -3 to +3. So as a compound inequality, I'd say -3 less than or equal to y, which is less than or equal to +3. In our next problem right here, y equals cosine of x minus 90 minus 1. So my amplitude is 1, haven't changed that. Again, I have no new period. Period will still be 360. And I will be shifted to the right 90. So since my period is still 360, I can label my x-axes normally, going by 90s. But now I will have to shift my cosine function right 90 and also down 1. So let's do this. Let's go 1, 2, and then -1, -2. My initial point, if I were to start, would start at 0, 1 for cosine, but this time I need to start to the right 90 units, and then also I'm going to start down 1 unit. And now I'm going to go through my typical cosine path. So I'm going to recognize that this is the top of my graph right here, and as I go right 90 units, I go down 1. And as I go right 90 units again, I go down again to -2. And then at 360, I start going back up. I'm at -1. And at 540, I once again reach a maximum point right here. And I will put some arrows at the end of these. If I did need to continue this, the next point to the left would go down 1. The next one would go down again, and then I'd hit, that local minimum over there. And so here we are. In our next graph right here, I have an amplitude of 1, but this time I have a new period of 180. So since I have a new period, instead of going by 90s as we traditionally do, I'm going to go ahead and go by 45s. So I've got negative 45 there, 45, 90, 135, 180, and 225 would be the next one. And so now I'm going to take all of my points and I'm going to shift them up 1 unit from where they typically would be in my sine graph. So I would start at 0, 0 for that first point, but now I'm going to go up 1 unit and start there. And now as I travel to the right 1, or 45 if you will, but 1 tick mark, I will go up to reach my local maximum right there. And then on my next one, I'm going to travel back down to where I started, over again, and now I'm at the minimum value. And over again, I am back to the middle. So I'll get another point there. And ending with some arrows. And another example right here. Let's go ahead and do y equals 3 cosine 1/2 x minus 2. So I've got a new amplitude. My amplitude is 3. So since my amplitude is 3, let's go ahead and label this 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. My new period is 720. So because my new period is longer, instead of going by 90s, I'm actually going to go by 180s. So I'll go negative 180, positive 360, this would be 540, and 720. And if I went all the way out here, 900. Now, cosine, starts in the, at 0, it would typically be the top, one of the local maximums, and it would be at 0, 1. But this time I've got a new amplitude of 3, so I'm starting up here, but now I need to shift that down 2 units. So I actually end up going right back to the same location here at 0, 1. Now for my next point, I have to realize that my amplitude is 3. So since my amplitude is 3, and this is a maximum point right here, what I'm going to do is I'm going to draw a little dashed line here along y equals negative 2, because that will be the middle of my cosine function here. So as I go over to my next value at 180, I will go from my maximum to the middle of the function, right here. And then as I go over one more point, I will go to a local minimum, and it looks like I'm actually going to need to go down here to negative 5. And then as I go over to 540, back to the middle, and at 720, back to the maximum. Now I will connect. So some things to keep in mind as we have our graph. Amplitude, reminder, is the distance from center, which was this dashed line that I drew here just to help us visualize it, from either maximum points or it could be measured from any minimum. Either way I look at it, distance is 3. Make sure that as we have new periods that you are labeling your x-axis appropriately. All right, now let's take a look at the last problem here. I'm going to show you a slightly different approach that you can do because as we begin to have a lot of these transformations, it can become overwhelming. So what I'm going to do here is I'm going to start by, identifying the function, and it's sine. So I'm going to make an xy table of values that I would have for like my traditional sine value. If there was no transformations at all, it'd be 0, 90, 180, 270, 360, and my sine values are 0, 1, 0, negative 1, 0. Now what I'm going to do is I'm going to go through all of these transformations just in alphabetical order here, and I'm going to apply those to this table of values. So if my amplitude is 2, that means that all of my y values will be affected. I'll just multiply them by 2. So the zeros stay, but that becomes positive 2, and this becomes negative 2. So now that's taken care of. My new period is 720, which means that I take all of these values and they essentially have, doubled. So in order to get from 0 to 720, this one would be 180, this would be 360, and this would be 540, and that would still be 0. And now that's been taken care of. Now the last thing that I have to do is go left 90, which means that I will take all of these values here and I will decrease them by 90 degrees. That's how I would go left. So I'm kind of running out of room here. What I'm going to do, I'm just going to decrease all of those by 90 and write it up here. So this one, minus 90, would go to negative 90. 180 minus 90 would go to 90. 360 minus 90 is 270. 540 minus 90 would be 450. And 720 minus 90 is 630. So as I go to label my axes here, I need values for y going from negative 2 to 2. So I could just label that by 1, so that'll be no issue. Since my new period was 720, I'm going to label, by 180s. So negative 180, 180, 360, just as I have done in the past. But now what you'll notice here is that with these table of values, I'm going to have some multiples of 90 that are not going to be on these tick marks here. So I will need to take that into consideration, and you'll notice that I'm going to add a couple of markings to my x-axis here. And I'm also going to write all of those down. So negative 90 and then 90, where my point will be. And did I have a mistake right there? No, we're good. And then I've got the next one I need is 270. Here. And then I need 450 and 630. All right, we're good. Sorry about that. Now I can just take all of these values from my coordinate table and put them where they go. So negative 90 comma 0 is my first point. And then at 90, I am at positive 2. 270, back down to 0. And so you'll notice it is the same shape again for sine. 450, down to negative 2. And 630, back up to 0. All right. End your graph with arrows on both sides. So by doing this with a table of values, I know some of you may prefer that. You're like, oh wow, now I can just kind of go through here, A, B, C, D, check them off as you do it, and just change your table of values, and then it's very clear cut. These are the coordinates I need to plot. Just take these points and plot them on your graph. Some of you may not like that. It's just another way for us to graph some of these equations, or functions rather, as they begin to have 4 or more transformations, because it can be really hard to think about at times. All right.